In this video, we'll compute the distance from Earth to Venus using some fairly simple mathematics involving properties of sectors of circles and the apparent size of Venus, also known as the angular size of Venus, when viewed from planet Earth. Let's begin with a few facts about planet Venus. First, the distance from Earth to Venus varies between 162 million miles at its furthest point to 67 million miles at its closest. And this differs depending on the orbits of the two planets and the time of year. The diameter of Venus will be another piece of given information that we'll use to find the current distance from Earth to Venus, and that diameter is 75,000 miles. This is a measure that would go directly through the middle of the planet. The diameter of Venus is 7,500 miles. Now, to determine the current, if you know that piece of information, the diameter of Venus, you can determine the distance from Earth to Venus if you know the apparent or angular size of Venus. And what that measurement is it's a measure of the angle from your point of view between the top and bottom of planet Venus, which at the time that this video is being made is 0.004 degrees approximately, rounded off to the nearest thousandth. 0.004 degrees. This is enough information to answer the question, what is the current distance from Earth to Venus? Let's do that now. This situation of viewing planet Venus from Earth can be represented fairly well as a sector of a circle. A sector of a circle is a fraction of a circle made up of a central angle, the radius of the circle, and a curved distance, often abbreviated S, which is known as arc length. In our situation, the sector of the circle would look something like what I'm outlining in red right now. And in our situation, the central angle of the sector is 4,000th of a degree. The arc length is 7,500 miles, and the radius of our sector is the distance from Earth to Venus. Now there's a formula that relates arc length, central angle, and radius, and it looks like this. This says arc length equals theta over 360 times 2 pi r. Now the 2 pi r is the circumference, is the formula for a circumference of a circle, given the radius of the circle. The circumference is the whole way around the circle. The formula for arc length is not the entire circumference, it's a fraction of the circumference, and that fraction is the central angle divided by 360. In our case, the central angle is 0.004, and the arc length is 7,500. Performing those two substitutions, this formula becomes 7,500 equals 4,000th of a degree divided by 360 times 2 pi r. And all that remains to find r, which is the distance from Earth to Venus, the current distance from Earth to Venus, because that distance changes, is to perform a few computations. First, to eliminate the fraction, we could multiply both sides of this equation by 360. 360 times 7,500 is 2,700,000. And then finally, to isolate r, we can just divide that 2,700,000 by 0.004, by 2, and by pi to arrive at a value of about 107,429,587. This is an approximation. I've rounded this off because there's a factor of pi involved. This is an irrational number. I've rounded it off to the nearest whole number. But when representing this situation with a sector of a circle, it's already approximated Additionally, the apparent size is approximated to 0.004 degrees, so there's no reason to round this to the nearest whole number. I'll round this distance off to the nearest million. That's what makes the most sense in this context. If the apparent size of Venus right now is approximately 0.004 degrees, then, based on the math that we just did, we could say that Venus is currently about 107 million miles away from planet Earth.